y panelistas que estén en línea. Cuando esté listo para comenzar la presentación, pulse el botón Iniciar emisión del panel de control de GoToWebinar para que los asistentes le oigan. El sistema le avisará cuando comience la emisión. La emisión está comenzando. Todos los asistentes están en modo de solo escucha.
Ciao, Alfredo Cotillon.
Sì, credo, vero. Che forse ci siamo incontrati da qualche parte quando sono stata a Avellino.
Quando sei stata, sei venuta a Avellino al Chrome? No.
Sì, forse con Malorni.
Ah, ma tantissimo tempo fa.
Sì.
Tu in che istituto? Dove sei?
All'IPBR.
All'IPBR.
Sì. Scusa perché siamo online con altri 100 persone all'ora 87, diciamo. Scusami, solo per avviare. Can you hear me? Can you hear me?
Hi, Gabby, can you hear me?
Especially you who are online connected. Let's see, Carla, can you hear me? Can you
Hi, Gabby, can you hear
just
me?
feedback if
Hi.
everything is okay with the connection
Gabby, can you hear me?
and also with the video? Hello?
Uy,
I am opening also the camera. Okay, people can see me. Can people hear me? Daria, can you hear me? Can you send me a message if everything is okay? I can see that you are connected. Okay. Zabala, someone. Okay. I have no feedback, but everybody is muted. Ima, can you check it also via from the Everything is okay. Oh, it was me because he... So then we will start soon. It was always with this technology. Okay. Ho visto dal tuo curriculum che no, infatti meno male che sei... Abbiamo avuto le tre febbraio che è un'occasione di celebrare. Penso che dobbiamo dire. No, una svolta storica di questa storia. Ora un contatto tempo determinato, ma perché viene non solo borsisti. Senti, allora magari mettiamo così, così ti riprenderà anche se qualcuno può dire. Io per poter vedere, ti lascerò praticamente. And then io vado in italiano. Okay, so I think it's time to start. Good morning to everybody here, and everybody who is following us online. It's a great pleasure again, and it's always a habit that we meet every Wednesday here because we have this seminar series of 10 lectures, 10 seminars here in Naples, and there are quite a few numbers who are online following us. So it started in 5th of February and it will last until 8th of April. And the title of the series is Extracellular Vesicles 2020 and Napoli. And the topic is from membrane biophysics to drug delivery. So it covers a very wide, this covers very wide aspects of extracellular vesicles actually. So first of all, today I really would like to thank all of them who are following us online. We have 87 registered participants through the GoToWebinar platform. And also I think for maybe this is the first day then we don't have really critical technical issues. So actually I think that they can see us and hear us. So it's a good news. So we would like to meet, as I said, every Wednesday at 12 o'clock for an hour. because we would like to promote extracellular vesicle research mainly in Campania, but also with the national and international partners. We talk from basic science to application about extracellular vesicles, and we would like to really discuss as much as possible, also with the people who are online. This seminar series is sponsored by the the Society of Extracellular Vesicles in Italy, and also by the VES4US European project. And you can all here you can see the connection. This is the link what you can use to join any of these seminars what we are offering now here. So this is, as I told you, our third seminar, and it's going to be by Chiara Cerdiello. I will introduce her soon. And the first two seminar was, the first was by Veronika Kraljevic from Slovenia, and the second was by Mauro Manno from the CNR of Palermo. They talked mainly on fundamental and biophysical aspects of membrane vesiculation, and also the biophysical tools what we can use for the characterization of the vesicles. And now we are going towards more applied aspects of EV research. So we will listen something today about large extracellular vesicles, size matters in tumor progression. So the our agenda for today is after this short welcome, we will listen Chiara, and then a discussion. And again, as every week, I would like to kindly, so anyone who is interested to have a pizza with me and with my group can join us for a nearby pizzeria. Just introduce. So welcome, Chiara. It's a great pleasure to welcome you here in Naples. I mean, you are in Naples, but here at the CNR. Chiara obtained his researcher position, I mean permanent position, just a few days back. So it's also maybe a moment of celebrating that one. So in 2020, she obtained this position at the experimental pharmacology unit, which is directed by Alfredo Budillon, who is also with us. So welcome you too. Of the Department of Research at the Istituto Nazionale dei Tumori, Fondazione G. Pascale. She obtained her BSc degree in biotechnology from the University of Naples, and also the MSc degree in medical biotechnology in 2011. And she got her PhD in medical and surgical oncology and clinical immunology in 2015 from the Luigi Vanvitelli University of Campania. She was in 2014 a visiting scientist, a visiting graduate student at Cedars-Sinai Medical Center in Los Angeles, California, and where she started to study extracellular vesicles under the guidance of Dolores Di Lizio, and she worked there on the roles of EVs in prostate cancer progression. She's a member of the advisory board of Young Researcher of the Fondazione G. Pascale, and she is also a member of International Society of Extracellular Vesicles, and got a Young Investigator Scholarship in 2018. She has main interest in cancer biology as biomarkers and therapeutic targets, and mainly on large oncosomes in the last few years. So her last publication, in fact, was it's just in February 2020. So it's another thing that we can maybe celebrate, and it's on large extracellular vesicles. Size matters in tumor progression. So it has been published by Cytokine and Growth Factor Reviews just a few days ago. So congratulations, Chiara, and this start your lecture. I will. So maybe we can just ask if can you hear us? Yes, they can. Okay. Okay, thank you, Gabriele, for your presentation. It was actually amazing. And thank you to let me share with you some observation about this world of large extracellular vesicles and how their large size can actually impact on tumor progression, maybe in a different way compared to the smallest population. So, first of all, what I'm interested in is the biogenesis of large extracellular vesicles. This appears interesting to me because most of the literature shows us that the biogenesis is linked to different signaling processes described, for example, has the activation of ROA and ROM-transcriptases, or the overactivation of AKT. And studying the literature, what came out is that all these molecular mechanisms are actually belonging to four main dynamics. So we have cytoskeleton rearrangements, viscosity of the cytoplasm, ions balance, and metabolic processes. All these processes actually work together, and they are able to link the signaling process to the mechanics and the biophysics of the plasma membrane. So the population I'm interested in is large oncosome population. Large oncosomes are actually atypically large because they can reach 1 to 10 micron size, and they are linked to a non-apoptotic process of membrane blending. What has been shown in the years is that large oncosomes shedding is promoted by the silencing of a cytoskeletal protein which is called DIF3. Its knockdown produces more blending of the cells and also the release of vesicles larger than 1 micron. Then another mechanism which has been described for the shedding of large oncosomes is the EGF stimulation in V145, and also the overactivation. I'm sorry that we cannot actually see the bleb here, but the overactivation of AKT through post-translational modification, the myristoylation, which make AKT always active. All these phenomena are linked actually to the amoeboid phenotype. In fact, one phenotype which is really important for the blebbing is the mesenchymal to amoeboid transition. This kind of transition actually passed through the kinases ROCK and RAC, and we were able to show in a recent paper that not only the bleb is enhanced, but also the shedding, and we imaged these vesicles by light microscopy on a gold surface. And these vesicles, large oncosomes, actually confirm their size that is on average around 5, most of the vesicles. So another important main aspect is that recently we were studying a system of prostate cancer, D145R18, which is able to bleb and shed more compared to the parental control panel D145. The reason for why D145R80 for us is not so interesting is that these cells are resistant to inhibitors of mevalonate pathways, so zoledronate acids and statins. So
So what we need to keep in mind is that V145R80 are more aggressive compared to V145, and we demonstrated that through the activation of P38, this cell line was able to invade more. They underwent epithelial to mesenchymal transition, they shed more pro-inflammatory cytokines, and they were more resistant to apoptosis. What we recently were able to observe was that through a metabolic analysis of the two cell lines, U145R8 and U145 were very different in the metabolic profile, and U145R8 were actually enriched in the metabolites linked to cholesterol. So about the biogenesis discussion I made a few minutes ago, what is interesting is that the resistance to mevalonate pathway, so to statins, inhibitor of the pathway of cholesterol biogenesis, enzoretronik acid, is able to impair not only the cholesterol synthesis, but also the proliferation of these GTPases so important for the large extracellular vesicles biogenesis, especially ROA and RAC. And in 2014, it was reported that the balance between the activated RAC1 and the activated ROA can actually influence the phenotype of cancer cells. So when we have a huge amount of RAC1 linked to GTP, here mesenchymal phenotype, but the cell can switch to the amoeboid phenotype if the amount of ROA GTP is implemented. Of course, every cell is not stopped in one or another phenotype, but there is the plasticity that depends also from the stimuli of the microenvironment. So then, what we were interested in and what the group of Dolores worked on was the question whether the large oncosome population was actually enriched in a particular set of proteins. So in 2015, Dolores group made, and I was there while they made this proteomic analysis comparing small EVs and large EVs. And what came out was a set of proteins. Some of them were actually important as biomarker and biomarker for large oncosomes. So a set of HSPA5, cytokeratin 18, and APH, with the absence of the typical exosomal markers, showed this specific population. And then what came also out was that large oncosomes resulted enriched in enzymes linked to metabolism. And especially in this case, they focused the attention on GOT1, which is actually an enzyme which is involved in glutamine metabolism. And we know that cancer cells are addicted to glutamine. So then, among these proteins, cytokeratin 18 has been identified as essential to detect large oncosomes in tissues. We show this in tumor tissues from mice experiments and also in breast cancer patients, where we have large oncosome-like vesicles positive to cytokeratin 18, and also first experiments in the circulation of mice. So we were actually working on proteins that can be also alternative to cytokeratin 18 to detect this large oncosome population. And we found that in our system, the 145R80, alpha-B integrin was expressed a tiny little on the surface of this blood. And we were able to show this positivity by immunofluorescence, by flow cytometry, and even by a kind of instrument which is able to image by a flow cytometry technique, which is called AMIS. And we can see here large oncosomes which are positive for alpha-B integrin on the surface, actually from both the 145R80 and the 145. Integrins, this was not, I mean, this was really important because integrins are basically involved in all the processes related to cancer progression. And they have been also shown to be important in exosomes to drive tumor metastases from the primary site. And for our system was in fact important as well because we demonstrated that in our D145R80, the integrin alpha-B was actually essential for the ability to invade more than the parental counterpart. Then we looked at patient tissues to see if alpha-B integrin-like vesicles were detectable. And what we noticed was that not only we were able to image these vesicles in lesion score 6 and even more in lesion score 8, but that the expression itself of integrin alpha-B was actually correlated to high lesion score and to the lymphnodal status of patients. Then another striking series of experiments on large oncosomes, which actually characterize them compared to smooth vesicles, are the experiments published by the Loris group in 2018 on DNA content in large oncosomes. So what they had before at the beginning was a difference in the content of protein and double-strand DNA between large and small vesicles. And what they found was that the amount of protein was almost the same in small versus large vesicles, but the amount of double-strand DNA was actually higher in larger beads compared to small. The second thing was really important is that by a series of experiments on patient plasma, after also some in vitro experiments, of course, they showed that large extracellular vesicles here were able to carry most of the DNA in the circulation. And finally, by sequencing experiments, they showed that tumor-derived large extracellular vesicles reflect the genomic makeup of the cell of origin. Even this experiment was made in patients, in blood of patients. So after this characterization of the content of large oncosomes, the next question was, which are the specific function of large oncosome population? They are really actually 1,000 bigger than the exosomes, the most famous component of extracellular vesicles. And large oncosomes have been actually studied as communicating with almost all the microenvironment cells, normal cells, endothelial, other tumor cells, and stromal cells. I think that the less studied until now so far component is the immune system cells. So which are the specific functions described for large oncosomes onto other cancer cells? So first of all, in 2012, group of Loris demonstrated that treatment with large oncosomes, that at the time were called shed vesicles, were actually able to induce the migration into cells directly and indirectly. So this means that even treating the fibroblasts with large vesicles, they were then able to induce migration with the conditioned media of treated fibroblasts. Then another interesting thing is linked to their large oncosome content in terms of enzyme of the metabolism. So what they showed in 2015 was that large extracellular vesicles are able to induce, to prioritize the glutamine metabolism in cancer cells compared to exosomes, and this function may be linked to the transfer of GOT1, the enzyme we were looking before. And then large oncosomes actually have proteolytic activity, and they contain metalloproteinases 2 and 9. So what we recently shown was another function belonging to large oncosomes. So we noticed that treating V145 cells with large oncosomes, we were able to induce the adhesion on vitronectin, especially with large oncosomes from R80, from V145 R80. And what was interesting is this effect was exerted through the integrin alpha V expressed on large oncosome surface. In fact, when we treated large oncosomes with an antibody blocking integrin alpha V, we were able to revert this function. And at the same time, even AKT on the inside the recipient cells was important to let the V145 adhere more upon large oncosome treatment. And another function we were able to observe is the induction of the invasion. V145, so cancer cells treated with large oncosomes, were able to invade more the matrigel, and this function was actually reverted in part when we block the alpha V integrin on large oncosome surface and when we block AKT in the recipient cells. On the microenvironment cells, there are a series of functions related to endothelial cells, which are able to invade more upon large oncosome treatment. And more recently, Valentina Musacchi made this experiment comparing the ability of large oncosomes and exosomes to induce the tubule formation assay of endothelial cells. And what came out is that large oncosomes are actually more efficient in this function. Even the induction of metastasis-associated factors and the pro-inflammatory factors in the stromal cells was induced by large oncosome treated. And finally, already in 2017, this experiment was actually interesting because Valentina showed that large oncosomes were able, compared to exosomes, to activate normal fibroblasts through the activation of MYC. And these functions were actually due to the AKT activity inside large oncosomes. Together with these findings, they also demonstrated blocking the internalization with dynamin of large oncosomes. They were able to block this activation of normal fibroblasts through MYC. So very recently, we made an experiment with this idea to have a kind of, to understand the difference between the factors shed by our resistant cells, by our aggressive cells. We made an instigator responder experiment. So this means that on one flank of the mice, we injected two responder tumors, V145 or V145 injected with matrigel. And these responder tumors were actually instigated by different instigators. What we found was that V145R80 were actually able to enhance the incidence of tumor of V145 compared to the vehicle, which showed us that V145 without matrigel are not able to grow. And what was also interesting was that in the responder tumor instigated by V145R80 especially, but also by V145 new matrigel, we were able to see the integrin alpha V expression. So the specific activity of large oncosomes is exerted in a braking way because in this experiment we actually made an ex vivo treatment of V145 injected in the flank of the mice without matrigel, and we treated these cells ex vivo with large oncosomes from themselves or from the aggressive cell line, and these are V145R80, which are more aggressive. And what we were able to see was that large oncosomes from V145R80 were able to enhance the incidence of V145 to almost 50%. So they were able to promote tumor engraftment either directly, and these are the survival cure confirming these results. So our conclusions are that large vesicles biogenesis depends on plasma membrane lipid and protein composition, and this composition is affected by cytoskeletal dynamics, cytoplasmatic viscosity, ion balance, and metabolic reprogramming, and specific intracellular signaling pathways. And second point, large oncosomes are large extracellular vesicles, 1 to 10 micron large, and they are enriched with specific proteins. Some of them, as AKT1, ROT1, or integrin alpha B, have been directly linked to malfunction of large oncosomes. DNA is more abundant in large extracellular vesicles compared to small, and the DNA inside the large vesicles actually reflect the makeup of the cell of origin. The size and functional role in cancer development and progression suggests the potential and specific diagnostic prognostic cancer biomarkers. And finally, the integrin alpha B expressed on large oncosomes surface could play, at least in prostate cancer, a prognostic role. So thank you to all of you for the attention, and to my group for the support and the 3D experiment and the finding mainly of the project.
Thank you very much for this very nice presentation, and the question. Okay. Curious question. Did you find some RNA other than the DNA in a lab? So the RNA actually, RNA so both microRNA are involved in large oncosomes. For example, this is a work with by Lawrence Group, which shows that in the and cancer survive this year exported potentially emergent. However,
can you come here in a way that they can also maybe repeat the question?
Okay. So for the macroRNA and messenger RNA, they are reported to be inside the large oncosomes, but especially the year 1227 was reported to be that when this miRNA was overexpressed in cancer cells, it was exported in large oncosomes. However, the reason for why we did not present this data on macroRNA was that, to me, the DNA data on the amount inside the vesicles was really striking and characterizing the large oncosomes. Thank you for the question.
There is an echo. Because there's an echo, but only when you are speaking, because you are we are asking to keep a little bit down.
So, okay, like this.
No, like this.
Like this?
Okay.
So, why I was, so the thing is that the fact that large oncosomes express are a kind of mirror of DNA inside the cell, and the mutation that the cell has is very important to use large oncosomes as biomarker, especially for the quantity of DNA, because we know that when we try to use extracellular vesicles in clinical practice, we have several problems of amount and several problems of reproducibility. So that data was important to me because the quantity can help us to use them in cancer patients, basically. And then, yes, it's true that the DNA inside large oncosomes is, let's say, normal, that reflect the cell of origin. But for example, for the protein, it's not always like this. For example, we showed that in our paper last year, we showed that some proteins which are overexpressed in the cell of origin are not exported in the vesicles. So if we think that the carbons, the content of vesicles are exported for a reason, for a functional reason, or for a communication reason, it can also be that not all that we found in the cells is inside the vesicles. And this is the first question. For the second question, and anyway, thank you, because it's a good question. I want to just switch slide. Because for the quantification of DNA, I need to take a look again to the graph. Yes, they make the quantification. Here they show the DNA nanogram per microliter, I think. So they use actually an instrument to detect, to quantify the DNA, but we, I was not part of this. Yeah. Yeah, I think microgram and nanogram of, because the quantification of vesicles is made by both a counter, so the nano, for example, and coupled with the protein quantification. So these two.
I cannot see. We have several.
Cannot.
Nowadays, one of the major challenge in oncology to follow the patients for during the follow-up and so on, avoiding invasive biopsy. Of course, when you perform liquid biopsy, you just get blood samples to find and wanna follow the tumors, for example, by detecting specific mutation related tumors. We end up with a big challenge with the whole DNA and a lot of rumors. So the idea that by purifying large vesicles derived directly by tumor cells, for example, with biomarkers like alpha B integrin or other biomarkers depending on the tumor. Then those vesicles get specific DNA mutation that resemble what is tumors, avoiding just picking up pre-circulating DNA, which is specific, but there's a lot of problems, could be a good point. So I think the idea that in this large vesicle we found double-strand DNA, I think is very, very interesting. And there are a lot of efforts now to compare, for example, DNA from circulating in the blood of cancer patients to DNA extracted from large vesicles from the same blood. And see if they can
Thank you. There's a very indication of how these large vesicles affect the these are showing that they are stimulating lymphodepletion and the genesis. But indication of how the immune response to reacting to these vesicles. Thank you for the question. Trouble with the microphone. I think that this is a field mostly unexplored so far. So what we know is that the internalization by immune cells is less efficient compared to other cells like cancer cells and fibroblasts and stromal cells. So this is what we know. But anyway, we also know that the interaction between vesicles and cells can also occur through other mechanisms, not only the internalization. So because nowadays in literature there is a growing interest in molecules important for the immune systems like PD-L1, which is expressed in exosomes, I think that we will study this field in the next future. And however, the prostate cancer is actually a cold tumor, so is a little more complicated to have the immune component for that tumor. Thank you.
Thank you very much, Sarah. I would like to make some general questions. If you have any idea and review the
Okay, so about the first question, I think that as just, the idea I have after our studies and the literature and the experience in the lab is that these large vesicles are shedded following a metabolic reprogramming of the tumor cells. This is really, the metabolism is really a striking condition in cancer progression. And I think that this is the basis of the rearrangement of the plasma membrane. So that's why we have this different sizing. And from one point of view, exosomes are more numerous. So the good thing about large oncosomes is that they are bigger. The bad thing is that they are less than the smaller counterpart. So I think that they can have absolutely some, advantage in the detection or in biofluids, even because there are few groups that work on large oncosomes. So it means that the experiment to get them from the blood and even from the cell culture media are actually the same, are more similar each other. But with exosomes, for example, there are many kits available now. So I think that there is a huge variability in the way to collect these vesicles. And about the integrin, for sure, there are several reports about integrins in exosomes. I don't remember if actually were specified that there was the surface, but I think so because it was reported in 2015 that these exosomes expressing integrin were able to crosstalk with the stroma to modify it to prepare the metastatic niche. So I think that definitely integrins are not only important in large oncosomes and are definitely important. In even the cancer progression is a process which for sure need all the factors that tumor cells shed. Then they may have some different specific functions. Yes.
There is one question from our attendees who are attending by online. So it's how do you isolate and characterize oncosomes? And have you isolated them from biological fluids or cell lines?
So I'm isolating large oncosomes by ultracentrifugation and gradient purification. Then the quantification is made by tunable resistive pulse sensing, which is published in the 2019 paper and even in other papers from Dolores Divizio group. And the other question was the biological. Yes, I'm struggling with this challenge because I mean, in some papers they have already been isolated from plasma, from mice and from patients, but we are looking for new strategy other than ultracentrifugation and purification to try to detect them in an easier way to be applied in a clinical laboratory.
What is the velocity of your ultracentrifugation step? Because the ultracentrifugation usually used for the small EVs.
Yeah.
So
yes, that is not. So the first centrifugation is not an ultra. So yes, it's 10,000. Is a 10,000 centrifugation. Then the pellet of large vesicles is purified by this unique gradient, which actually run at 100,000 purification. Then I collect 1.15 gram ml of no, because in the paper of 2015 and in all the paper of large vesicles, we noticed that even if there is a little difference in the gradient, 1.10, 1.15 is the pellet, the starting pellet, which is different because we actually work on 10,000 G. 10,000 G. Then that pellet is purified. And then this pellet purified is visualized by tunable resistive and MTA and DLS for the impurity, because of course we have a large, an amount of small vesicles contaminating, let's say like this. But all our experiments are made with, for example, for D145 R80, D145 are made with the two preparations. So we are actually totally convinced that the part which makes the difference is the large part, which have been shown even by FACT immunofluorescence and confocal microscopy and cytometry.
So thank you for your very nice presentation and your interest also. So see you next week. Next week is going to be Ramesh Bokka, who is going to give a talk about this project on nanotome. So nanovesicles isolated from tomato. So thank you again. And also I would like to say many thanks to all who joined us online. Thank you.